talking about the type of the technique which RAG is and all. So what we will do is we'll just ask about the advantages of RAG. So let me just type that. What are the advantages of RAG? And when I do that, I should be getting the answer similar to what is mentioned here. There is a 3-step answer which is mentioned here. Reduces misinformation, can be customized, and supports dynamic updates. So if you see here, it is giving the exact response which we will be talking about retrieval-augmented generation with Mistral, Ollama, LangChain, ChromaDB, Python and WSL. We will be building our own local AI-powered knowledge system which will be based on this tech stack. So let's get started. So this will be our implementation wherein we will be pulling the Ollama in WSL2 system, and then we will have the Ollama client which will load the local model in the form of Mistral LLM, and the LangChain will help us which will be writing in the Python script which will help us in creating those embeddings, shaving that into the vector database, that is the ChromaDB, and then relieving the relevant context. It will also help us load the specific file which we want to use as a data source for the learning or the knowledge, and it will also work with the LLM and Ollama client to generate the final answer, pass the retrieved context to the LLM, and for the embedding in different embeddings for retrieval. We need to first understand what is retrieval-augmented generation. Retrieval-augmented generation is an advanced AI technique that enhances large language models by retrieving relevant information from external sources before generating the responses. This approach helps in improving accuracy and reduces the hallucination wherein it tries to assume an answer and provides more contextually relevant answers to your questions. So here is the flow where you create the first the data through a PDF or a folder which has the list of documents, or a CSV file which has the information. Then it is extracted and it is chunked into the different sections of the data, and then it is done. There is an embedding of that specific chunks. After that, it is put into the vector database, where the vector database becomes the part of the retrieval-augmented generation. The first step is when you have a query coming in from a user, you go to the embeddings, you create those embeddings of the question which the user has asked. It goes to the vector database. From there, the relevant data is picked out, and through the LLM, which is in Mistral in our case, a response is generated by Ollama through LangChain, and that response is given back to the user. So this is the complete flow of a RAG application. Now, how does RAG work? RAG operates in 2 main stages, that is retrieval and generation. The system searches the database for a set of documents to find relevant context based on the user's query, and then the generation, where the retrieved information is combined with the original prompt, allowing the language model to generate informed responses. Now, the benefits of RAG application is the key benefits of RAG is it improves your accuracy, reduces the misinformation by grounding responses in retrieved data, and enhances the contextual understanding, allowing AI to incorporate domain-specific knowledge dynamically. And it reduces the model retraining needs. Instead of frequently updating the model, RAG enables AI to access new information without retraining, as it is accessing the location of data. Supports transparency. AI can cite sources, enables users to verify the information. Now, in use cases of the RAG, we have customer support applications, medical AI applications, the legal AI system, and enterprise knowledge management systems can be made out of this RAG application. Now, the challenges for the RAG application: you have the source credibility. AI relies on the retrieved documents, which may not always be accurate. Latency issue: retrieving and processing external data can slow down the response time. And then the complexity of implementation, which requires integration with database and vector search system. So these are the different areas of how RAG works. Now we need to understand also the Ollama. Ollama is the open source AI platform designed to run large language models locally on your device. So you pull the Ollama server as a client into your system, and it allows the user to interact with AI models without relying on the cloud services, ensuring privacy, speed, and customization. A large number of LLMs are available on Ollama site, so we'll be talking about it right now. First, let's understand what are the key features of Ollama. That it runs the LLMs locally and it does not require internet, and there is a data privacy. It supports multiple models. It works with models like Mistral, Llama 3, Gamma, and Phi 4. It is fast and efficient, optimized for quick responses and low latency. It is customizable. User can fine-tune models for specific tasks and cross-platform. It was available on Windows, Mac OS, and Linux, and will be running on WSL. Now going to the site on Ollama, you can see there are a number of LLMs available which Ollama integrates with: DeepSeek, Qwen, Phi 4, Mistral, Llama 3.3 and Gamma 3. This is the latest snapshot from the Ollama, or there are more number of models which you can integrate with Ollama. Now moving on, what is Mistral, which we'll be using as an LLM in our system? The Mistral is again an LLM developed by Mistral AI, a French AI startup specialized in high performance AI models. It is designed for enterprise application. It offers advanced reasoning, coding capabilities, and multi-model understanding. So all these three are available in this. Now the key features of Mistral is it is state-of-art AI model. It competes with the similarity and has similarities with the GPT-4o and the Cloudy Sonnet 3.7. And optimized for enterprise use. It is having two different versions, wherein we'll be using the free version, and then there is an enterprise version as well. The multi-model capabilities can process both text and images. It has efficient deployment and works in hybrid cloud, on premises, and VPC setup as well. It is cost effective, offers low pricing compared to the DeepSeek V3. Now going to the site, Mistral has a good amount of documentation, and that's what we were talking about, the free model and the premium models which it provides. Now what is LangChain? LangChain is a framework for building application powered by LLMs. It simplifies the development of AI applications by providing tools for retrieval, orchestration, integration with various data sources and APIs. Now key features of LangChain is LLM integration or RAG based application. It allows the AI to interact with external APIs and database like an agent or a tool, and it has memory and state management, and also multi-model support it provides. How LangChain works: it takes the user input and then searches the database. For our case, it will be ChromaDB for relevant context, then passes the retrieved data to the AI model, which is the Mistral, over via Ollama, and then the response generation happens. The AI generates an informed answer and the output to the user is provided. Here I have provided the site for the LangChain, and let's see the site now. So this is the LangChain site, and it has a good documentation on what it is, and also other details pertaining to the LangChain usage. It has it can be used with Python. So I am launching the Python. I'm going to be working on the Python application to integrate LangChain with Ollama for Mistral LLM. Now moving on, we have a ChromaDB which will be used in our application as a vector database. So ChromaDB is an open source vector database designed for AI application, particularly for retrieval augmented generation, that is the RAG workflow, and it enables efficient storage, retrieval, and similarly search of high dimensional data such as text embedding, and that we'll be showcasing it now. In key features of ChromaDB is optimized for AI workflows. It's as a vector search. It has high scalability. It integrates with the AI frameworks and is lightweight and open source. Now, how does ChromaDB work? It forms the text embedding creations. Storage in the ChromaDB saves the embeddings for fast retrieval. Now, user query processing searches for relevant embeddings based on the query, and the contextual retrieval retrieves the most relevant text chunk. LLM response generation, it passes the retrieved context to the AI model and gets the output for the user. I have included the link for the site for the ChromaDB, and the ChromaDB has again a good documentation on how it works as a vector database for AI and machine learning applications. So now we'll move on to the actual implementation. We will be doing the steps which is required to implement this RAG application. So let's get started with that. So the first step is to create to set up WSL, and the way you can set up WSL is installing the Windows WSL on the Windows to run the Linux based development environment, and you install the Ubuntu inside the WSL. So the command which you do is you do a WSL minus hyphen install -d and Ubuntu. Now you need to enable the WSL to do this step, and once you are done, then the Ubuntu will install on your machine. I will not run this because I already have Ubuntu, but what we can do is we can go ahead and check the WSL, verify the installation is done, and it can be done through this command line, wherein you can check WSL -list -verbose, and you can see we are running a specific version of Ubuntu. Now next step is to install the Git if you don't have it already, and the way you can do it is first you need to run you need to first now go to the Ubuntu. So I'll launch the Ubuntu command line, and in this what you need to do is to first update the system packages, and that is through this command line. Since I already updated, right now I will not be running it, but basically this is how you will update the system with the latest packages. The next is you will update is you need to create get the Git. So the next step, next command line which you need to run is to get the Git, and once you have installed the Git, you need to configure the Git through the different command lines. The command line for configuring the Git is this. So I'll just paste that here, wherein you need to enter your global username and also your global email. And through this you will be able to configure your Git. Again, this is all command lines which I have already run, so I will not be running. Moving on to the next step, you will install the Python, and the way to install Python is something which you can do through a command line like this, wherein you will take the install Python 3 and you will install the venv of Python 3 as well. Now you will create a virtual environment of the Python through this command line. The virtual environment is required for us to run our LLM. So this is the way you will set up the activate your virtual environment, and you will also provide is the source, and the next line is wherein you will be setting it up as the source of the virtual environment. The next is you will create new Git repository through the make directory command line. So consider you are creating a project like this RAG project. You will make the directly, and you will get into that specific project, and you will do is git initialize, something like git init. Now these are the commands which you will run, and once you are done with this, then the basic setup is done. Next is the installation and configuration of dependencies. So the next dependency which you need to install is the Ollama. The Ollama install can be done through this command line. The command line is a curl command line, wherein we try to get the Ollama installer and install it, and then we can check the Ollama is installed or not through this command line, which is Ollama list. So we can just do this command line, and it will give us the list of models which we have in our system. I already have the Mistral installed in my system, so that is why it is showing that. If you don't have Mistral, you will run this command which is Ollama pull Mistral, and it will pull the latest version of the Mistral in your system. The next is to install the other dependencies which is LangChain, Ollama and ChromaDB. So since we have already installed the Ollama, that is fine, but if we haven't installed that, then this is the command line through which you will be installing the LangChain, Ollama and the ChromaDB. Now after you install this, you should be able to go to the next phase of the implementation, which is the data preparation and retrieval setup. For this, what we need to do is we need to create a Python script. So I'll show you the Python script right now. So this is the Python script which we will be using. This has a simple imports from specifically from the Ollama LLM and Ollama embeddings. So what it does is basically it loads and prepare the data also from the data.txt. Now the data.txt is a file which has a simple data which talks about the RAG augmented generation details. So we'll be asking questions around this only, so that we are able to get a specific answers which are relevant to what we have provided as input file. So that's what we are trying to do through text loader. And then what we are doing is we are splitting the large document into smaller pieces for the vector database storage from this line, wherein we are doing a from LangChain lang splitter. And what we do next is we generate the embeddings using the Ollama, wherein our model is Mistral, and we create those embedding functions and then store the document chunks in the ChromaDB. Now after you store that, you do write a retriever wherein you are doing as retriever, you are retrieving the stored chunk, and then you generate you create the RAG chain, wherein you are referring to the retriever which you have just created with the Ollama model, LLM model which you are utilizing here, and also the kind of chain which you are using, the type of chain using. And then you pass the query which the user has asked. You ask the user to provide a query, and on that basis you will be generating the response based on the document which you have provided and the model through the embeddings. So that is how the whole flow will work, and this is something which you can run in your system through so this is our environment wherein we have set up the RAG environment, and now we are going to run the Python script which we just talked about. The Python script will run, it will go ahead and let us know if we are ready to ask a question, and if that is there, then we will be going ahead and putting a question which will be similar to what we have provided as an input to the system, which is talking about the type of the technique which RAG is and all. So what we will do is we'll just ask about the advantages of RAG. So let me just type that. What are the advantages of RAG? And when I do that, I should be getting the answer similar to what is mentioned here. There is a 3-step answer which is mentioned here. Reduces misinformation, can be customized, and supports dynamic updates. So if you see here, it is giving the exact response which we had provided, which the input which we have provided, and it is giving us the exact similar response back. Now let's take a new ask a different question based on our input which we have provided. For example, what are the steps? The RAG approach consists of 2 main steps, right? So we'll just ask what are the steps in RAG approach. So we'll just ask what are the steps in RAG approach, and when you do that, we should be able to get an answer similar to what here it is, the retriever and the generation, rather than anything from the internet, but specifically from this document. So as you see now, it is giving the exact same response, the retrieval and the generation. So it is trying to fetch the same response which we have provided as an input through a text file into the system, and it's trying to give us response from there itself. So that's pretty much about how you will generate a local source of information through your documents, your folders or CSV files, and you use the LLMs and the LangChain and the Ollama orchestration with Python on WSL to generate the application like this to serve your needs even without the internet. So that's pretty much. Hope you like the video. If you like the video, press like and subscribe to the channel. Have a nice day.